Welcome. We'll discuss polymorphism in C++. Polymorphism is the advantageous feature of OOP which allows us to declare the different functions, or we are giving some extra meaning to the functions as well as to the operators. So here poly means many and morphism means we are providing different shapes or different states of the function. So polymorphism is basically divided into two categories. One is compile time polymorphism and the another one is runtime polymorphism. So compile time polymorphism, it is the information which is available at the time of compilation. Compiler selects the appropriate function at the time of compilation. It is also known as static binding or early binding. As the variables, as the functions are already declared before the compilation, this is known as early binding. So every variable is associated to that particular function before the compilation, and that's why it is known as early binding. Then runtime polymorphism. Now the compile time polymorphism is available before the compilation, whereas runtime polymorphism is available during the execution, during the running of program. It is achieved when the object's method is invoked at the runtime instead of the compile time. It is also known as dynamic binding or late binding, as the variables, as the functions are declared when it is called or when it is invoked during the execution, and that's why it is known as late binding. Then we'll see the types of compile time polymorphism and runtime polymorphism. Basically, compile time polymorphism is exhibited by using overloading, whereas runtime polymorphism is exhibited by using overriding of the functions. Now, overloading is exhibited by it is classified into two categories. The one is function overloading and the another is operator overloading. So function overloading means we can provide the same name to the different functions when the functions are having different types of arguments and the different number of arguments. So the process of having two or more functions with the same name but different in parameters is known as function overloading. So we can use the same name of the function in our program. For example, suppose if we want to display some result or some values of the variables in different classes, so we can use the same name for all the functions, and if we want to display the different values in one class also, then also we can use the same name for displaying all the things. That is the major advantage of the function overloading. Now and a major advantage of the function overloading, and it increases the readability of the program, because you don't need to use different names for the same action. So programmer doesn't have to think which name is to be given, because whenever we are giving the names to the functions, it is recommended that give the names such that it will give the purpose for which it is written and all. So if I'm using the same name, then C++ allows me to use the same name. Now we'll see the example of function overloading. Now here in this function, in this example, I have used one class in which I am using the two add functions. The first add function is having the name int add with the two parameters. It returns the value, it returns the sum of the two parameters int a and int b, whereas the second function is there which is having the three parameters and which is having the same name as the int. There is no any ambiguity to invoke which function at which time, because here the number of parameters are different. So this is the declaration of the class, declaration and definition of the class. And then now in main we will call the function add 4, 6. Okay, whenever I am calling this add 4, 6, it will call the function which is written here, this add. Okay, so I'll just sorry for this. Okay, when we are calling this, then this function will be called, and whenever we are calling the function add with the three parameters 4, 6 and 7, then this function will be called. So whenever we are calling the function with the appropriate parameters, then compiler will be calling the same function. There is no any ambiguity, there is no any confusion between the compiler and all. Okay, so this is all about the functions and all. So here, okay, now by using such type of functions we can implement or we can exhibit the function overloading, which makes the program very much easier. Okay, now we'll see the operator overloading. The operator overloading is the function or is the procedure which allows us to declare the operators or give the extra meaning to the operators of C++, which is not possible in C. Okay, so operator overloading, it is a compile time polymorphism in which the operator is overloaded to provide the special meaning to the user defined data type. Now we can define the class. Class is nothing but the user defined data type, and we can create an object of that. So we can use the object for operator overloading and all. For example, suppose if we want to add the two complex numbers, then I'll declare the complex as a class, and in which I'm going to use the real and imaginary number, and then real and imaginary, these will be the members of the class, and then I'll create the object of the class so that it will hold the real and imaginary number, and then we can go for addition of complex numbers. So suppose if I want to add the real of one complex number to the real of the second complex number, then I can use the operator overloading. It makes me very much easier, and very much flexibility is available by using the operator overloading. So we'll see more on this operator overloading. Operator overloading is used to overload or redefines most of the operators which are available in C++. Operator overloading allows us to give extra meaning or some higher meaning to the built-in operators, not for the user defined operators. Okay, so here it is used to perform the operations on the user defined data types, but not on the user defined operators. So advantage is that to perform different operations on the same operand. So it is allowing me to add the two integer variables, to add the two complex numbers, or to add the two objects in this. Now whenever we are overloading the operators, C++ doesn't allow us to overload some of the operators. These are scope resolution operator, then size of operator, then member selector operator, that is dot operator, which is used to access the members of the class by using an object, then member pointer selector, that is asterisk. Already asterisk is overloaded because we are using it for multiplication also, as well as for declaration of pointer also, as well as for accessing the values of the values which are stored at the pointers, that is also. So the next operator is ternary operator, that is conditional operator. We cannot use these 5 operators for overloading. Again I'll repeat, we cannot overload these 5 operators: size of operator, then scope resolution operator, member selector operator, then member pointer selector operator, and the ternary operator. Then there are some rules for overloading of the operator. So existing operators can only be overloaded. The new operators cannot be overloaded. So we can't declare our own user defined operators, and we can't overload these operators. Remember this. The overloaded operator contains at least one operand of the user defined data type. We will discuss it in the next example. We cannot use the friend function to overload certain operators. However, the member function can be used to overload these operators. So there are some operators where we cannot use the friend function, otherwise we can use the friend function. Then next rule is overloading of unary operators through a member function take no explicit argument, but if they are overloaded by a friend function, takes only one argument. Then overloading of the binary operators through a member function takes one explicit argument, and if they are overloaded through a friend function, it will take two explicit arguments. So you have to remember all these rules while operating the operator function. Whenever we are going to overload the operator, or whenever we are writing the operator overloading function, that function will be having the keyword, that is operator, and then the symbol or then the actual operator which we want to overload. So the syntax for overloading an operator is return type, then the keyword operator, and then the actual operator, and then the number of parameters or the parameters list. Here I will see example of unary operator overloading. Here I am using a class ABC in which A, B, these are the two data members, and here I am writing one read function for reading the values, and one display function for displaying the values of A and B. And the another one is I am using operator minus, void operator minus. Now minus, that is the negative sign, is a unary operator, so I can use it for my program. So void operator minus, and in this function I am writing that A, whatever the value of A is there, minus it means negation of that value will be there. So A is equal to minus A and B is equal to minus B. This is my class ABC. Now in main I am declaring object of ABC class. So ABC obj1. obj1 is the object of ABC class, and by using that object I am invoking and calling the function read. So obj1.read. So before application of the unary operator, let's say the value of A is 10 and value of B is 20. So the output of obj1.display will be A is equal to 10 and B is equal to 20. Then I am calling the operator overloading function. So that operator overloading function will be called in very much easier manner. Just we will use the operator where which operator we are using for overloading. So here I am using the unary operator, so minus obj1.display. So whenever I am calling this minus obj1.display function, it will call the function which is overloaded by the operator minus. So A becomes minus A and B becomes minus B. So whatever the value of A was 10, now that becomes minus 10, and whatever the value of B was 20, so that will become minus 20. So this is a simple way to use the operators, and also if I am using the binary operator, I have to pass an object of the user defined data type, that means class, for the binary operators. Now whenever we are going to use the operator overloading, we have to remember such some things. It allows us to redefine the way operator works for user defined data types, user defined types only, not for built-in types. So we can use the operators only for user built-in built-in operators. Here equal to sign and ampersand operator, these are already overloaded by default in C++, so we can't overload it again. Then one more and very much important is that we cannot change the precedence or associativity of the operators. So we can't change the actual meaning, the conventional meaning of the operators. So these are the important points related to the operator overloading. So if we are going to use this overloading, the program becomes very much easier, the code becomes very much easier, but we can handle so many complex things to make it very much easier for the programmer. So it is a very powerful tool of OOP. Now we'll see the runtime polymorphism. So runtime polymorphism is implemented by using the overriding. Overriding means we can change the contents of the function, we can change the contents of the variables as and when it is required during the execution. And this is implemented by using the virtual keyword or virtual functions. So here for just an example purpose, I have used one class which deals with the different shapes. So the parent class is shape class, in which I am using virtual void draw. Now virtual is the keyword which will allow us to declare the virtual function and which will be accessible by all other functions. So here public virtual void draw. Then here I am just printing drawing. Then in the second class I am going to use derive the shape class in the public accession in rectangle class or rect class, where I am declaring the function draw, in which I am just printing the message as drawing rectangle. Then in the third class, in the third type of class, I am deriving the shape as a parent class in public accession, and I am deriving the circle class through this. So in the circle class I'll just use the same function name with void draw, no any change in the return type and no any change in the name of the function, and here the message printed will be drawing circle. Now this is the class for shape class. Then in main I'm going to use the pointer for the class. Whenever we are using the virtual functions, then we have to use the class object pointer for that. So here shape pointer s, it is the object pointer, and sh is an object of the shape class. Then I can declare the objects for rectangle class and circle class. So for rect class I am using r1, and for circle class I am using c1 as the object. Then I am assigning the address of sh, that is an object, to object pointer s. So s is equal to ampersand s, and then I am calling the function by function draw by using the object pointer. So s arrow draw, it will call the function from the shape class, that is the parent class. Then I'm changing the address which is stored in the object pointer, that is I'm changing it to r1. So s is equal to ampersand r1, and then I'm calling s draw, s arrow draw. So it will call the function which is available in the rectangle function. Then I'm changing the address which is stored in object pointer to c1 object. So s is equal to ampersand c1, and then I'm calling again the same function s arrow draw. Then it will call the function which is written in the circle class, and that's why the output on the code will be drawing. That means it will invoke the function which is available in the parent class. Then secondly, it will call the drawing rectangle, that means it will call the function which is available in the rectangle class, and then the function will be called which is available in the circle class. So though the names of the functions which are available in the different classes is same, but there is no any ambiguity for the compiler which function is to be called, which function is to be invoked when and all, and this is possible due to overriding of the function or due to the runtime polymorphism. So this is all about the different types of polymorphism, and it is very short discussion of the polymorphism. So thank you.